trying to make a chart, and you can't see it, but it's got everybody's work plan. It's got all the dates every day from now till the end of till Thanksgiving. And then what I tried to map on here is what deliverables are each team going to have. And I found that with only a couple of exceptions, nobody really described their deliverables. They only described your activity. He never said, on this day, we will have a preliminary report on such and such, or anything like that. So my initial idea was that with the help of Blackboard, I would be able to kind of keep track of how everyone's doing, and at certain key points, there would be something that you would produce that I could then look at and give you help with and give you feedback on, so that I could say, okay, you're on the right track, but you need to add this, or this is great. And right now I can't do that, not based on what you gave me. And I also noticed that in one case, Ian, Susan, Jasmine, your team, there was no time frame or anything. It was just steps without a date. No, nothing had a date, even a week identified, that this would be week 5 or week 6 or any particular day. So the way it is right now, you're kind of left on your own. And what's going to happen, we're going to get to the end of the semester, and I'm going to ask you to produce your reports and documents, and it may be the first time I see anything. So the other option we have is that we set aside one class every so often where everybody gives a status report. Every team gets up and says, here's the status of what we're doing, and then we can kind of get a feel for how things are going. And I think that's really what I'm going to do. But I do want you to go back and really pick some target dates. Not week 3, but this day we will have this. And kind of shoot for those. And even if you don't make it, which happens quite often, and it's not pulled together until the day after, it's still better than not having any kind of target date for a product. That's what a deliverable is, a product of some sort. And it's, it doesn't have to be a final product. It could be a very preliminary, it could be a very outline form. And so if your responsibility on the team is to be, say, the programmer, then you might have a product that you have to produce called list of spaces. And so you pick a time when that is going to be done. So it doesn't have to be big chunks of things, it could be individual pieces. Because one of the skills that you have to learn as a programmer in doing programming is planning your work, staying on task, achieving the goals that you set. And sometimes you have to be able to know how to do mid-course corrections when things aren't flowing the way you thought they would, and then you got to regroup and say, okay, this didn't quite work out. What are we going to do? How are we going to revise our work plan? So I'm testing you on how well you can do those things, because really, in the end, having that capability of being organized and being productive and being able to plan and execute is more important than your ability to collect certain kinds of information. I mean, there are other skill sets like interviewing that you need to develop, and knowing how to extract from a whole bunch of information the real essence of what's there and what's important. Those kinds of skills, but a big skill is the management skill. So I just want to share that with you because it is important, and fortunately it's not turning out the way I hoped it would. Now, it's not too late if you want to submit to me, sometimes certain deliverables. That would be great. So today, I'm going to be talking about something that doesn't really apply to your projects, because everything that we need to cover in this class doesn't relate directly, in every case, to the School of Architecture redesign. And so what I'm going to talk about today is financial feasibility analysis, which is a very important component of course-grained programming. Can we get the lights? We used to have a class here at the School of Architecture for many years called Building Economics. And that class covered a whole bunch of things that were important to a future architect who wants to be involved in the sort of the budgeting and cost and planning, early planning stages of projects. And it's something that the Architectural Accrediting Board expects you guys to know or to have learned a lot about. And we don't have a class like that anymore. So I'm kind of taking advantage of this class to cover this area, which I used to be quite involved in. In fact, I even went to the University of Wisconsin and got a certificate in financial feasibility analysis and planning for architects and developers. And I've had commissions with clients, corporate clients, where they've asked me to go through this kind of initial analysis of their projects, which I'll share one of those with you. So financial feasibility analysis. Why should architects even care about this? This isn't something that you normally associate with an architect's skill set, being able to do financial analysis. It's something you expect developers, bankers, lawyers, financial consultants to be involved in. But I contend that this is where the most important decisions are made. And you're not at it because they don't think of you as having anything to contribute. So what I'm going to cover is 2 techniques for doing financial feasibility analysis related to development projects. And a lot of this is geared towards clients that you might have that are developers. They're in it to make money. They're approaching you as the architect saying, I've got this property, I want to build an office building, and I want to make a bunch of money on it. And so you need to be able to talk their language when it comes to finances. Main concern of owners and clients is money. Now, it's not always true. They also may be concerned with the aesthetics of it. They may be concerned with the redeemable social value of it, and so on. But buildings are very important investments. They're big investments with high initial costs and long-term costs. And in order for the building to have a good return on the investment, it needs to perform efficiently. So if you have a private building that's an income building, it has to be efficient. You can't have a bunch of wasted space. You can't have a bunch of wasted stuff. You can have some space that might be considered to be wasted, but it might be there to provide an image for the building, or it might be there as an amenity that everybody appreciates, like wide hallways or something. So some clients are in the business of using buildings as a commodity that they're selling, leasing, using it to earn income. So these are what the client wants to know, and is going to ask you to help with the initial cost. And that's a lot more complicated than you might think. What are the life cycle costs of the building? How much initial long-term revenue will be in the revenue stream? And what's eventually the ROI, the return on investment? These are the things that are going to be concerned about. And there are additional concerns that have more to do with the lifespan of the building. How long will it be before I get my investment back, my initial investment? I put up money up front. I want that to be back in my bank so I can invest in something else. How long should I keep the asset? These are seen as commodities, assets that you keep only as long as it makes sense economically, financially. And how's the building affecting the performance of the workers? That's a tough question because there's different theories about that. There was a famous study called the Hawthorne study. And in the Hawthorne study, they took a whole bunch of office workers in the Hawthorne company, which I think makes, I forget what they make, but in their office building, they changed the lighting in one section of the building. They made it brighter. They thought, okay, we need to increase the lighting level to improve performance. And performance went up. And then another section of the building, they reduced the lighting, thinking that performance was going down, but performance also went up. And the reason that happened because it showed that management cared about the worker, and we're trying to do something to benefit the worker. So their motivation was greater and their performance went up. So it isn't always a simple relationship between the physical environment and performance. It's sort of a lot of more complicated. It has to do with the interpersonal relationships between management and workers and a number of other things. And then, of course, they want to know when is the building going to become a liability. And at that time, it's time to unload it or to remodel it, renovate it, expand it, or something else. And the reason that this is actually a chart from my master's thesis that I put here, when I did my thesis on time impacts in architecture, this was one of the diagrams that I used, where if you build a building, normally, you overbuild it a little bit, because you allow for a certain amount of growth and so on. So this is this initial phase in the building, the initial part of its lifespan. And if it's a healthy economy and so on, and the organizations are growing, this is the organization and its demands being placed on the building, and you reach a certain magical point where there's a match between what the building provides and what your demands are on the building in terms of space, for example. But then if you keep going and you keep owning the building and your organization still keeps growing, you end up with overutilized space. And you can only tolerate that for a certain amount of time before it becomes so dysfunctional that your people working in the building are really having serious problems. They don't have a place to put a desk, they don't have a chair, and so on. So then you reach a crisis point where you have to decide what to do. At this decision point, do you sell the building and buy a bigger one? Do you add an addition to the building? Do you rearrange everything to find space and become more efficient? So you go through this catastrophic event here with the company and the building. And then eventually, so you're slightly overutilized, your building is slightly underutilized again because you overdo it. You don't make it exactly what's needed, but you make it a little bit extra. Like if you're adding an addition, you make it a little bit bigger. And then you go through the same cycle until you reach a point where you can no longer do anything to accommodate your people because the building just can't do it anymore. So when you get up here, you don't have any choice. You have to abandon the building and so on. So this is just one scenario that could occur in relationship to buildings and performance over time. So architects like to think that they're experts in everything. I mean, it's in our nature. If we believe we're expert, we are. And one of the areas that we like to think that we know something about is in this area of financial feasibility and so on, but we really don't know very much about it. The client thinks you know nothing about it. So architects still have to prove that they should be invited to the table when in that very first meeting when they're trying to decide on it from a business perspective, from an investment perspective, and so on. Usually the architect comes on board after decisions are made about where the building is going to go, how big the building is going to be, and what kind of building it's going to be. Then you're kind of given that and say, okay, give us a 20-story office building on this piece of property. But maybe it should have been an 18-story office building, or maybe it shouldn't even be on that piece of property. So you have to learn the language, the concepts, techniques that developers use, especially speculative commercial developers. So we're not normally involved, we're not invited. Key architectural decisions are made at those meetings that you're not part of. And then you're given a ready-made solution. You're kind of become the exterior decorator. You're given, in many cases, you're given the footprint, you're given the volume, and you end up figuring out what skin to put on. Yeah.
But since we assume that architects don't know financial stuff, how do you get them to change their concept? Because they said that they'll meet before
Yeah.
they decide on inviting the architect and making figures, but it's after they have invited you that they're expensive. But how do you change that to make them invite you in the initial stage?
You know, it's not easy. There are lots of architects out there who are architect developers that do both. They do the whole thing. Tom Portman, for example. And because there are some people like that, that are design build firms, that actually own the buildings, that you know, do a whole turnkey process. Clients that are really knowledgeable, they'll probably seek out an architect like that has already proven that they know how to sort of talk about that as part of the project. Most sort of standard run-of-the-mill architects probably would not be asked because no one thinks they really have enough knowledge to contribute. And it's really up to individual architects on how they want to market themselves. If they want to market themselves as somebody who can assist in feasibility analysis, then they may be invited. And if they can show a track record in doing that. So there's different phases, different steps involved in doing financial feasibility analysis. And again, this is part, I think, of coarse grained programming. This is where a lot of the important decisions are made. There's the initial feasibility review, and then there's a detailed development of what's called the pro forma, where you study, you go through all of the factors, and you figure out what the return on the investment is going to be, the ROI. And then once the programmer has put together the initial program, then it goes through a financial feasibility analysis. Again, it cycles. You do the initial feasibility, and then once the program has been fleshed out, then you do another run through the feasibility analysis to see if anything's changed. Maybe the building got bigger, maybe it got smaller, maybe there's more equipment involved, so maybe it's a more expensive building, and so on. And then, once you have a schematic design and you have what I'm calling here a design program, then you go through another financial feasibility. Every time you look at the budget, you're doing a financial feasibility analysis, run through again. And it helps if you have a model. This is a computer model that you put in the new numbers, it cranks it out, it tells you what is now going to be the return on your investment. Because that's a fluid thing, it goes up and down based on how the cost picture is evolving. And then after design, there's another assessment of what is now the return on the investment. And then after the completion of construction, you do a final financial feasibility analysis. Because maybe it turned out to be more expensive to build than everybody had assumed. There were a lot of change orders. There was a bid process. The lowest bid was selected. The contract was based on the lowest bid. But then there were a lot of things that occurred during construction that caused the construction budget to go up, which impacts the feasibility analysis. So an important part of that is cost estimating. You guys learn cost estimating in any other classes? Because it's really important. Cost estimating, able to do cost estimating, something you need to do, and it's something you need to learn how to do. And there's all kinds of ways of doing it. There's different guides, different programs, different things it means, and so on. But there's something called the initial rough cost estimate, and that's a per square foot rough estimate based upon market standards, upon what has it cost in this region to do a Class A office building per square foot. And so times the total area, and you end up with your initial rough cost estimate for initial feasibility purposes analysis. And then more detailed, this becomes more and more refined as the project progresses, your cost estimate. So here's an example of a cost estimate breakdown. And there's a number of things involved in cost estimates. There's hard costs and soft costs. And the building construction cost is only really one element in that. There are all the other things that come into it, like the equipment costs, the site development costs. So there's a total construction cost, which you could talk about as kind of the hard cost. And then there's a number of other costs that come in. The cost of acquiring the property, the cost of chairs and tables that are movable equipment that are not fixed in the building, the fees, contingencies, administrative costs. Sometimes there's permitting costs, a number of other things. So your total budget is very often considerably more than the construction costs. So in doing a financial feasibility analysis, you have to work with your total budget required, not your construction costs. So looking through what the steps are in project cost estimating, that total project cost estimating, you have a number of steps. Like I said before, you start out with the preliminary, then you go with the programming and its cost analysis, then the schematic design and its cost analysis, the design development cost, construction, what bids come in and what the bids are, which may be different than what you had estimated they would be. And then your final cost with all change orders and everything else added in after construction. So then throughout this whole process, the client is standing there asking you, well, this is still feasible. Now, what makes it feasible? Obviously, if you don't have the money, and it costs more than the money you have or have available to you, it's not feasible. The benefits have to justify the expenditure. It has to be a significant enough return on your investment that you don't want to take that money and invest it in something else that will give you a better return if you're in it to make money. And the performance of the project as a money-making machine has to be greater than the minimum threshold that you've established. Like someone might say, I want at least a 10% return on my investment. Or I can go to the stock market and do better. So you have to meet that threshold. Now there's two ways of going through this. And when I used to teach this, I would go into a great deal of detail on both of these. One is called the front door, the other is the back door. The front door is probably the most common. You figure out your project cost, and then you figure out how much money you need to come up with from the bank or from your cash resources, and then you figure out how much your return on your investment is going to be. The back door is sort of the opposite of that, where you start out with how much money you've got, and then you figure out what kind of a building you can do, how big it can be, and so on. How much can you spend on the building and have a return on that investment. So if you come in knowing you've got $10 million to invest, you want the whole financial feasibility analysis to show that you're going to get the return on that $10 million that you hope that makes it worthwhile for all of the pain and suffering you have to go through during a construction project, and the risk that you're taking in that whole process has to be worked out. So I'm going to run through quickly what a front door analysis looks like. And this is highly simplified. Keep that in mind. And I've done this for clients, professionally in my practice. So what you do is you work out your costs, your building costs, your fees, your total, your permitting costs. So now you're figuring out what your cost breakdown is. So here's your cost breakdown, all the different pieces that you have to take into account. So in this example, you're starting out with your hard cost, construction cost, 5.5 million. The total project cost is 6.6 million. So there's another, all these other things, there's another 1.1 million. Then what you have to do is incorporate into that your cost of borrowing money, your financing cost. Because most developers don't use their own money, or they use as little of their own money as possible. So what they do is they figure out how much can they borrow to finance the project. That comes with a cost. First of all, your loan to value ratio is how much of the total value can you borrow. Like, is it an 80% loan? Is it a 70% loan? Usually it's less than 80%. So you add that, how much you can borrow, what percentage of the cost can you borrow, what is your total project cost times the percentage to give you how much you can borrow, and once you know the percentage that you're being charged for that loan interest, the percentage on the interest, then you can figure out what your financing cost is. And this is all stuff you know because you borrowed money for any reason, bought a car or something. There's a difference between the cost of the car and your total cost. So in this case, the financing cost of the project is $447,000. That's assuming that 75% of the project is being financed at 12%. So you're paying a lot of interest in this case. Mm-hmm. So your initial project costs, remember there's all these different project breakdowns as you go through the project, as the project evolves. You have different ways of looking at it. Your initial project cost, you have to worry about the difference between a construction loan and permanent financing. There's a carrying charge during construction. The construction financing cost is different, structure is different. And there's fees and permits and things during that initial period. So in this case, the carrying charge for that 1 year that the building is, let's say it takes 1 year for the building to be built, would be $10,000 plus your previous amount added to your initial cost of the project. And now the project cost has increased because of the impact of that the financing of the initial construction. And then once you've gone through your construction loan, then you seek permanent financing through a mortgage type of loan. So you're borrowing, you're trying to, this is your total project cost, taking into account that construction period, times the amount that you can borrow. In this case, they're giving you 80%. And so this is the amount you're borrowing, 5.6 million. So then you have to figure out what is your debt service on that loan. How much are you paying to have that loan in interest on an annual basis? And so in this case, you're paying $663,763 every year to service the loan. And that includes principal and interest. So what operating income do you need in order to be able to support that and have a return on the investment? Well, you need to know how much you have to pay out every year, and this is an annual basis. That's your debt service to service the loan, plus your expenses. The building has expenses. It has utility costs, it has maintenance costs, it has ongoing expenses. So you end up with an expense rate. The expense rate is based on your square footage, and there's usually a guide. Yeah.
Would it be total usable floor area?
No, it's usually your gross area.
Okay.
The total building. So this is the income you need every year. 1.863 million. That building that you have built, that the client has built, needs to earn that much a year, which breaks down into a monthly income of 155,000. That's what you have to earn in rent, or at least, or your tenant has to, somehow you have to end up with that. Either it's a retail establishment and has to earn that much, or whatever it is. So that tells you what kind of income you need, and then you have to figure out, well, is that a feasible amount given the market? So you look at how much rent do you need. That gives you a net monthly rent or income that you need coming in. But then you have to factor in a vacancy rate. If this is like an apartment building, there's always going to be some vacancy, or an office building if you have a rental project. So in this case, 8% vacancy rate. You have to factor that in because that's not giving you income. So you end up with, in this case, you have to charge $21 a square foot rent. Now, then what you have to do is look at the market and say, what are comparables in this area? What other buildings that are similar to this building, what are they charging? So am I going to be able to get $21 a square foot? Or is that way higher than the market? Nobody's going to rent my building, so it's not a feasible project. So in this case, it's not feasible because for this example, the competitive rental rates are $18 a square foot. So you have to tell your client, I'm sorry, the way this financial feasibility analysis, very rough, quick analysis works out, you're not going to make money on this building, you're going to lose money. So I would advise you not to go ahead with the project. Now, you've lost an architectural commission, but you've gained a fee for being a management consultant. And maybe the client will be so impressed that you didn't fall into a conflict of interest problem that they'll turn around and hire you for their next project. And on and on and on. You establish your credibility that way. So that was the simplified glance at front door financial feasibility analysis. And I didn't go through the back door. That's a whole other similar analysis, only it's kind of in reverse, where you start out with the amount of money you've got to work with, and then work back from there to how big can the building be, how much rent you have to charge. And the other part of that is you pick a competitive rental rate. You say, okay, this is how much money I've got, and this is how much rent I can charge based on the market. What kind of building can I build? And will it make money based on construction costs and all those other costs? Or are those costs going to be so high that I can't make a good return on my investment? So if you're going to want to, again, if you want to be at the table during this part, you need to be, somewhat conversant and comfortable in those discussions. Does anybody have any questions? I know this is not related at all to your School of Architecture project. Please don't feel like you have to do a financial feasibility analysis, because again, in your project, the budget is given. You know that the legislature has given the university a certain amount of money earmarked for this building. And it doesn't really matter what it is. Because we could hypothetically say it's $20 million. But it doesn't, I guess it could impact your programming. If you know you've got a really healthy budget, you can program in a lot of luxuries. But that's not what you should be doing. You should be programming in what should be there. Not anything less, not anything more. So I do have a couple of other things that I've got online on Blackboard. I've got an example of a project I did for a client that did this. I've got an example of a student project. When I taught this, I gave an assignment where every student had to go out and find a piece of vacant property in Tallahassee and get all the relevant information about the property. It had to be a property that was for sale. So they had to talk to the realtor, get the sale price of the property, then look at the zoning of the property. They had to look at what could be built, what's the highest and best use of the property in terms of how much can you put on it, what kind of buildings can you put on it based upon the zoning code. And then they had to look at how much financing can they get from a bank. They had to sit down with a banker and say, okay, I'm a student and I'm developing this hypothetically to learn about financial feasibility analysis. And they had to pretend they were like the developer, and they had to run through the project and find out what kind of financing they could get, how much they could get, and what they would be charged in interest. And then they had to go through the analysis to see if it would be a sufficient return on the investment. And I have one of those, and maybe I should show it to you quickly. Does that sound like something you want to see? Okay, this was a piece of property that the student found on Thomasville Road here in town. So here's the property, it's Thomasville Road, North Thomasville Road. And there's the property description. They had to know what the property identification was because they had to go to the Leon County Property Appraiser's site and so on. They had to know the zoning and on and on. In this case, there's two properties. There's this property here and this property. They were combining two properties to make it viable. So this is just description of the demographics around the property, which helps you to understand whether there's a market. So what other retail complexes are in the area? What other competitive sort of businesses are in the area? Are there any potential, if you were thinking of making this into a retail, are there any customers in the area? And what kind of access is there to the property from roads and I-10 and so on? So this is what developers do. They look at all this kind of stuff, figure out whether it's going to be a good property to develop. And so now this is looking at the costs, the appraised value, the sale price. In this case, just under $1 million. And this is real. These are real numbers that the realtor gave the student. And so there's the two properties. One property is worth a lot more, $1 million. The other one's only worth just under $200,000. There are taxes they have to take into consideration in their annual costs. And, so there's total property costs, add that up, of 1.2 million, that's the purchase property. Here's the analysis of the property in terms of things like access, circulation, traffic, bordering businesses and properties, the kind of stuff you do with site analysis. Have to worry about contours. Is it a buildable site? Is there going to be any special construction problems with it? What's the zoning? In this case, it's AC. This is a few years ago, so I think the zoning may have changed. It's an activity center zoning. This is a description of what you can do on that zoning and the kinds of uses that are allowable uses. Setbacks, they had to know what the setbacks were, so they knew what was the buildable footprint, the building, and what the parking requirements are, because that eats up a lot of the site. So here was what was being proposed as the building. It was going to be a mixed-use complex, retail complex with office, retail, and parking. And the square footages came from the previous analysis of what can the property accommodate, given zoning, given setbacks, given all of those factors. Trying to maximize the development of the property through something called the highest and best use. So here was the cost breakdown for that project. You can see the building costs, fixed equipment, so on. And this is the initial cost analysis based upon percentages, based upon square footages. This is not the detail later on cost analysis that comes out of a design building or a built building. So this is the loan information that the student got from the loan bank. That was the amount that had to be borrowed, 48 million. The total that had to be repaid, this seems like a very, very generous interest rate. The monthly payments would be 141,000. That's what it costs to pay off your loan, keep the debt service on the loan. In January, it came to 1.7. In this case, the developer is putting 20% of the cost down as a down payment, getting a 30-year loan with a rate of 5.9, getting it on 80% of the cost. And so the amount of interest that they're paying in the end is going to be 2.8 million. So here's the overall assessment. They have to ask $25 per square foot. So the monthly income would be 2.8. That's the office space, then the retail space. Now, what they don't have in here, which I faulted them for, is they don't have a vacancy factor. So, there are retail spaces around town that have been empty for a long time, particularly in strip malls. You'll have, like the strip mall that has Newberry and the Publix and off of Blairstone. That's had several of their store units have been sitting empty for several years now. So that has to be factored in. So the total income from this complex that includes office space and retail, in this case, is $365,000 a month. Now, is that enough money for it to be a sufficient return on the investment of the developer or the investor? So, according to this, yes, it does. I don't quite buy it, but according to this analysis. So you can see the annual income minus your annual cost minus your taxes equals your profit. So it's very simple, all your costs, what you have left over is your profit. In this case, on an annual basis, they're saying that you'll have a profit of 2.66 million. That sounds like a pretty good profit, but you have to remember how much money are they putting at risk in this case. So what is your monthly income? Because that's what you really exist from month to month. Pay out, you get your monthly rental income, you pay out your monthly costs for things like utilities and so on, and taxes, different kinds. So according to this, you're making a monthly income after all expenses of $222,000 a month. I think you want to go invest in developing. But you got to remember, this is probably a building that is one of these pre-engineered metal buildings that you see that are as cheap as possible with no architect involved, only an engineer and a catalog. So, is that 222,000, 100,000 a sufficient return on the investment? Okay, here's the investment potential analysis. Over the 30-year loan period, maintaining full occupancy, which is a totally unrealistic assumption, it's got a potential of generating a profit of almost $80 million over 30 years. But 30 years is a long time. If it only has half occupancy, 50% occupancy, which is actually likely to happen, or is possible, then it would only have a profit of 40 million over 30 years. But that's over 30 years. So, according to this conclusion, the monthly costs provide approximately 157% cushion, allowing for building maintenance if you have no profit. Now, you'll notice in the earlier analysis, it didn't include building maintenance, and it didn't include utilities. And so I think the numbers need to be much more reflective of reality. And of course, this is a student project. So, based upon the acquired information that they collected from the bank and from the real estate people and from the city, county, and so on, and the scenario of putting up a retail office development, the profits seem to outweigh the risk, making it a financially feasible investment. But what it doesn't really address is what is the return on the investment? What is the ROI? So this is an example, and I have at least 10 of these that have been done for properties all around Tallahassee. Almost all of them, with the exception of strip malls, came in saying that you can't make money on it. Strip malls, cheap strip malls, are the only things that made money, made a good return on the investment. That's why you see them all over the place. And they just keep building. Because the people who do this stuff, real estate people, developers, and so on, they run the numbers and they figure out that that's where you make money. Now, unfortunately, you reach a point of oversaturation where there are just too many strip malls, and so therefore the vacancy rate factor starts to come into play, and other things. So it's an interesting aspect of architectural practice. It doesn't appeal to many people because they think it's kind of unseemly. It's not a dignified sort of enterprise for designers and professional architects to be so caught up in this, but it's reality. And in fact, there is leverage in here to impact good design. And it comes down to discussing how much of the building, what the building budget should be, for example. If you only have a developer that wants to build the cheapest building humanly possible, then you probably don't want to be at the table. But if you have a developer who's interested in their image, they're interested in performance, they're interested in branding their company, and so you could be there to give them a realistic idea about what the building construction cost is going to be and what it should be in order to get the kind of building that they're looking for. And then run the numbers. And if that shows that there is still a return on the investment, even with a better quality building, then you've done a service to the community as a whole. Then you don't have these ugly buildings that you drive by and you kind of try to ignore, that are just a metal shed with a bit of fake brick on the front.
Mhm.
And that's sort of my soapbox. You guys have anything to add to that? Anybody here have experiences in doing this kind of stuff? Anybody here a closet villager? Anybody worked in the development game? Also on Blackboard, I added a couple of other things. One is a PowerPoint on how to do a highest and best use analysis. And the third thing is an example of a project that I did with Professor Alfano when we had architectural practice together. We had some commissions. And in this case, we were hired to look at the building over here that is now the Bond Community Health Center. That was formerly a state of Florida building that was being leased by a private corporation here in town as their headquarters building. And they hired us because they were overcrowded in the building and they needed to make a decision. Do we continue to stay in this building, purchase the building and renovate it and add to it? Or do we look for another building that's an existing building and move into it? Or do we buy a piece of property and develop and build a brand new building? And we went through that whole analysis from a return on investment point of view. And in the end, they decided to build a brand new building. And I was involved in the project all the way through. I was involved in helping them hire the architect, the contractor, and the building has been up for 8 years now, and they're it's just north of I-10 and just west of on the north side. It's French Benefits Management, which has their world headquarters. And the CEO and founder of the company then hired me twice to design his building, his home. And the first time, that whole process caused him to get divorced. And so then he didn't want to stay in the same house, which he only lived in for a short time, so I had to design from another house for his new wife. And so I designed 2 houses for this guy and did all this work on his corporate headquarters. Okay. You know, I would appreciate any information about any reports or deliverables or anything like that. So I guess that's it for